Good morning and welcome to a discussion of money and the way that time actually does equal money in our society. This is true. Our language is full of metaphors, and the metaphors contain grains of truth. So, one of the things that we say is like, how do you spend your time? Invest your time wisely. And we talk about time as though it's money. This is a metaphor that's baked into the English language. And here is the mathematics behind why this is true. Okay, let's take a look. One way that time is related to money is through something called simple interest. Simple interest is interest that does not compound upon itself. The original amount invested, and we call the original amount invested the P, and P means the principal. The principal is the amount that is deposited, okay, the amount that you invest up front. All right. And the principal will earn interest, but the interest does not earn interest. We're not adding the interest on to itself in that way. Okay. And then we have these formulas here that we're going to use, and we're going to notice this is a linear function. The reason is the amount of interest that's being earned throughout the life of the investment never changes. So it creates a constant slope. So when we graph these, they would create arithmetic series as we look at how much money is there at the end of year one, how much money is there at the end of year two, and so on and so on. And they would be, we would start here at time zero, and that would be the principal. Your y-intercept would be the principal, and then it would grow like a line. Very boring stuff. Okay? No, doing the math is not boring. Investing in this way is super boring. You're never excited about these investments, but they might be very safe or something. So, if David borrowed $2,300 at 7.5% interest annually, earning simple interest. So, these are all important ideas. Okay, we're going to need these numbers everywhere. So, here we want to first understand what these are. First, let's write down our formulas. The amount is going to be equal to the principal plus the interest. So let's write that down. The amount in the investment is equal to the principal plus the interest. And the interest is equal to the principal times the rate times time. This is what we're using this formula for. This formula here determines how much interest is being earned. We take the amount that's been invested, multiply it by the rate, multiply it by time. Boop, put it in there. Okay, so let's write that down. I is equal to P times R times T. Okay, so here's the time, 10 years. Okay, so let's write down our numbers. The amount is equal to 2,300. That's not the amount. My goodness. Hey, Mr. Jennings, you're making mistakes already. Oh, good, thank you. The principal. The principal is the amount that's invested up front. Okay. Now, the rate is 7.5%. So the R is equal to, write it as a decimal, 0.75. My goodness. It's just my brain is not keeping up with my hand. My brain is like, you already wrote down the zero, but it knows that it's 0.75. It's so weird. It's so weird when I'm talking. I just don't write down what I'm saying or thinking. 0.075 is this as a decimal. The way you do that is you move the decimal once, twice. Okay, so there's the decimal. So I have this is 0.075, which I wrote down there correctly. So, amazing. Wow, what are the chances? Okay, and this earns simple interest, and the time is equal to 10 years. Now, let's put all of this together and find out how much he'll have to pay back in 10 years. Okay, so the amount that he will have to pay back is equal to the principal, $2,300 plus the interest. The interest is here. So I'm going to write down the principal times the rate times the time. Okay, so I could actually factor out. I could factor this too. You could factor the P out, and you would have P times 1 plus RT. That would be another way to write this formula. Anyway, this is all easy either way. Amount is equal to 2,300 plus 2,300 multiplied by 0.75. The reason is when 10 multiplies by this, it moves the decimal place once. So 3/4 of this is what he's going to pay in interest. So what's 3/4 of that? Well, again, you can watch me stare up at the ceiling and do the mental math, but it's just much faster and error-free for me to do this and multiply by 0.75 equals $1,725. So the borrowing the money cost him $1,725. That's how much it cost him to hold on to this money for 10 years using simple interest. And then how much will he have to pay back? Well, the sum of these two things. So let's just go over here. You've already got that number on your calculator and do plus 2,300 equals. There you go, 4,025. So in order to hold on to that money for that long, it cost him 4,000, and he pays back $4,025 total. Therefore, he will have to pay back $4,025. Write it out as a sentence so that you can show that you know what the answer means. Therefore, after 10 years, he has to pay back $4,025. There. Full solution. I'm pretty confident that I got that one right this time. Okay, so now this one is asking us, this one is telling us the P, that's the principal, that's how much he borrowed. And then this one is telling us the amount that he paid back. So we can find it, we can look very easily and say he paid $50 in interest. But now what we're asked is, what simple annual interest rate did he pay? So we're being asked to solve for R. All right, so let's take a look and see how we can do that. Okay, let's just write down our values. P equals 1,000. The A equals 1,050. And now let's go ahead and put this into some of our formulas here. So amount equals P plus I, the interest. That's total paid. So we can use this to calculate, I've already said it, the I is equal to 50. Okay, so we can see that, right? This plus some number equals this, so 50. And let's use our formula for I. I equals P times R times T. Okay, so we know that I is 50. We know that P is 1,000. We know that R is what we want to solve for. And we know that time is 6 months. 6 months is another way of saying half of a year. So let's write down 1/2 for time. Okay, now we can solve this equation for R. So I'm going to multiply both sides by 2 and divide both sides by 1,000. That's another way of saying multiply both sides by 500. Okay, see, half of 1,000 is 500. So my inverse operation here could be to divide both sides by 500. And that will give me the answer for R. I'm skipping steps. Maybe I shouldn't skip steps. So for those of you that are comfortable doing that, that's great. But if you're not, here, we'll do some extra. We'll just take your time, Mr. Jennings. These lessons are very short, so you can take your time. So 50 is equal to 500 times R. Just multiply that times that. And now do the inverse operation, Mr. Jennings. Good, much better. Okay, now divide by 500. Now they see that this cancels this, and divide by 500. And they see that this is 1/10. Do you see that that's 1/10? I see that that's 1/10. 50 divided by 500 is 1/10 equals R. Okay, there's the answer. That's the interest rate, is 1/10. But that's a very strange way of saying the interest rate. Usually we express interest rates as percents. So if I want to express that as a percent, I could first convert it to a decimal and then convert it to a percent, or I could just know that that's 10%. Okay, so the way you do that is 1 divided by 10 equals 0.1, and then I move the decimal place once twice, okay? And that would be 10%. Okay, and then we finish with a sentence that looks like this. Magenta will be how we write our sentence. Therefore, Joshua paid 10% simple interest. Not so bad, eh? So now we can solve for the rate. We can solve for the amount at the end. You could even solve for time because these are linear. It's just all just lines. Okay, so now compound interest. All right, so compound interest is far more interesting. And because you're young, it's far more exciting to you because the more time you have, the more powerful your time is because of the nature of exponential growth. The more time you have, the more you can see that slope increase is the value of compound interest. So when we're looking at these formulas, the letters mean basically the same thing, except we have a new letter that's come in here, the C. And the C has to do with the compounding periods. If we only compound the interest annually, which means once per year, yearly and annually are synonyms, then we wouldn't need a unit on this. We would just know that they're exponential functions, and we graph them. Okay. And we graph them. Yeah. So, but because we can compound interest according to different time frames, some investments will apply interest to them once per year. Other investments will apply the interest twice per year. Those would be called semi-annually. If you receive interest quarterly, 4 times per year, then that's called quarterly. Monthly is 12 times. Weekly is 52 times. Bi-weekly is another one that we want in here. And that means once every 2 weeks. That would be 26 times a year. And so then our C would be equal to 26. You see, I didn't write down the 2. I had to write it down after. It's so strange when I'm talking and writing down numbers at the same time. Okay, so biweekly. Yeah, so that's another one that we want in there. These still create exponential functions, so it's very exciting. And let's take a look at how we work with some of these ideas here. So n is the number of times that interest is applied. The way you find that is you take the number of years and multiply it by the compounding frequency. The interest rate is the amount of interest that's applied per compounding period. So what you do is you take the rate of interest as a percent and divide as a decimal, and divide that by C. Okay, so it will make more sense when we take a look at an example. Now, some of you might be thinking, well, it looks like the more often I apply interest, probably the better these investments will do. And in fact, that's true. A higher frequency of compounding means that you earn the interest sooner and are earning interest on the interest sooner. So they are better. What if we applied interest continuously, like an infinite number of times per year? Like all the time interest is being added and adding on to itself. And that does not go to infinity. It actually goes to this formula here. So here's another formula that we'll add. The amount that you'll earn from an investment compounding continuously is equal to the principal multiplied by the number e, which is a special exponential number. It's a constant. It's a real number, so it's got all kinds of decimal places that go on to infinity. This is a really good approximation here. And so e raised to the power r, which is the interest rate, and t is the time. Okay, so this is actually a simpler formula to work with when we're compounding continuously. But we need to have this button E on our calculator. We need to know how to use that. Okay, cool. Let's take a look at some examples. If you deposit $10,000 into a savings account that compounds interest quarterly at a rate of 8% per year, how much will you have after 5 years? Let's highlight our important numbers. This here is the principal. This is what we invest up front. The amount is compounded quarterly. So quarterly tells us C equals 4. There's 4 compounding periods per year because it's compounded quarterly. The rate is 8% per year. So that means our interest rate is equal to 0. Careful, Mr. Jennings, 0.08. I did it correctly. Hooray. See how I really had to slow down there. How much will we have after 5 years? So time is equal to 5. Okay, so now we've got all of our data out of the question, all of the things that we want. Now let's take a look. We're looking for how much, okay? How much will you have? So we are being asked to solve for amount. That's very important to know. Like, what are we looking for? We're looking for how much we're going to have. So let's write down our formula. The amount is equal to the principal multiplied by 1 plus, because that's the 100%. Remember, we have to add this for our growth factors, for exponential stuff. 1 plus the rate as a decimal divided by the compounding frequency, all raised to the power time times the compounding frequency. Okay, so there you go. That's what this formula can look like. Is that the same way they write down the formula here? I say. No, it's a little different. I is R over C, and N is T times C. Okay, so what I have here is R over C and T times C. That's how I did it, a little differently. Okay, A is equal to, here, P is 10,000. Show the whole question, Mr. Jennings. Okay, there you go. P is 10,000. 1 plus R over C. So let's do R over C over here. R over C equals I, and not the fancy math square root of -1i. This is the interest rate per compounding period. This is equal to 8 divided by 4. So that's 0.08 divided by 4. This is equal to 0.02. Okay. There's the number that goes here. So this will be 1.02 inside here. 1 plus that is 1.02. And T times C is the number of compounding periods. And that's equal to 8. Sorry, no, that's equal to 5. This is time. T is 5 multiplied by C, which is 4. So that's equal to 20. Okay, so I'm going to raise this to the power 20. This is, again, not something that you want to do in your head. So you go in here, you clear out your calculator, you say 1.02. Let's move this so we can see the work. Multiplied, raised to the power 20 equals. So our amount of money that we'll get in 5 years at 8%, compounding quarterly, will nearly increase by 50%. It increases by 49%. So let's use 40. Let's just take that number and multiply it by 10,000, and then we can round to the nearest cent. Okay, multiply this number by 10,000 equals, and then we will have this amount of money. 14,859.47. 47? Yeah, cool. Okay, so that is the amount of money we will have. And then the last step here is to write down your sentence answer. Therefore, you will have $14,859.47. Make sure that period is very clear. Okay. Now let's carry on. Okay, how much do you need to invest now to have $20,000 in 10 years with an 8% interest rate, this time compounded monthly? Okay, so let's do our work here. We are now solving for how much do you need to invest. That is what we want to find. So we are basically being asked, what is the principal required to have this amount in 10 years is T, 8% of the rate is equal to 0.08 now, and the C is equal to 12. We're compounding monthly, so We want a C of 12. All right, so now let's do our thing here. So the interest rate that we're going to be earning over this time is 0.08. It's R divided by C, so 0.08 over 12, and that's equal to, we can just keep it as that if we really want to, or we can write this down as a, this is 2/3, but it's 0.003 repeating, right? And I'll show you here, Claire. This is a point where doing mental math, we are going to lose people. So divided by 12 equals, we can take, so 6, of course, it's 2/3, not 1/3. See, talking and speaking at the same time. So that, it's a lot easier to just leave it as this. See, I don't want to write that down. I want to write this down. Okay, so let's carry on. So that's our interest rate. And our number of compounding periods, this is equal to time times C. Okay, and so that's going to be equal to 10 times 12, which is 120. Okay, so now we can write down our formula. The amount is equal to the principal multiplied by 1 plus I, which is the rate divided by C, R divided by C, all raised to the power n. Okay, and we can put everything in except for principal. Principal we don't know, so let's substitute everything in. A is equal to 20,000, and this is equal to principal multiplied by 1 plus 0.08 divided by 12 raised to the power 120. Okay, so now let's punch this on the calculator, and we're going to divide by 1 plus 0.08 over 12 to the 120, and we're going to divide both sides by that. Notice that this will cancel this, and we'll be left with P on that side, and P is equal to this. So this is what I can punch on the calculator to find it directly. But I'm going to punch this one first. So here, I have this number here, that's I. I'm going to add 1 is equal to this. And now I'm going to raise that to the power 120, which will take this rather close to 1 number and make it rather larger. So that will be, sorry, what am I looking for? Right, to the 120 equals, so there, the amount of growth. So what we're seeing here, this is the amount of growth. We're going to grow by 122% in this time, according to this stuff. If we have 10 years, 8% interest rate, compounding monthly, your money will grow by 122%. This is basically 2.22. Okay, so now we just need to divide 20,000 by this. So I'm going to put this into memory, into the calculator. I'm going to write the number 20,000, and then I'm going to say divide by what's in the memory. Memory recall equals there. This is the amount of money we need to invest. $9,010.47. That'll do it. That'll give us $20,000 in 8 years. All right. So here we have solved for P. P equals $9,010.47. For some reason, I used a comma. There, $9,010.47. So now write your sentence answer. Therefore, you must invest $9,010.47. Why am I doing a comma? It's so strange. To have $20,000 in 10 years. There. That's how you do that type of thing. You use your formulas, and sometimes you manipulate your formulas to get answers. Okay. Now, here's a harder question, but we've got nice numbers here. 10,000, 10 years, 10% interest rate, and we're going to compare compounding annually or compounding continuously. Okay, so now we're going to need to use this continuous number. So here, let's take a look at our numbers. Our principal is 10,000. Our time is 10 years. Our interest rate is 0.1. This is 10% expressed as a decimal. This is equal to the rate. It's also equal to I because here we're going to compare two situations, and I'll do one situation in red and the other situation in black. So this one is compounded annually, so C equals 1. So we're not going to need that number because dividing by 1 and multiplying by 1 is the same. Okay? And then there's also continuously. So continuously, here, this is different. And we're going to use amount is equal to the principal multiplied by this funky number E raised to the power R times T. Okay? A is equal to PERT. Cool. Okay, so over here, we're going to, and then another important thing to find is what do we want to find here? How much more money will you have? Okay, so we have to compare, is what we're saying, compare. All right, so you want to compare these two things. So we're going to evaluate that one, we're going to evaluate that one, and we're going to compare using subtraction, everybody. We're going to find the difference. So let's take a look. All right, so first question, I said we'd use the red. All right, that means what am I going to use for a red pen of shame if I have a mistake? It'll be the purple pen of shame. That's actually more fun. That's because it's alliterative. The purple pen of pain. Maybe it's the purple pen of pain. Okay, so anyway, here we go. We will have how much money here? Well, our principal is going to be multiplied by 1 plus the rate, 1 plus I, raised to the power T. Because we don't have a C here, I can use this formula. All right, so here, A is equal to the principal is 10 grand multiplied by 1 plus R, so that's 1.1 because this is 0.1 is R raised to the power 10, okay? The amount is equal to, just crunch it on a calculator, clear everything, memory clear. Okay, so now we have 10,000 multiplied by 1.1 raised to the power 10 equals, we will more than double our money. Sounds really good. Okay, sounds really nice. Notice that if we were earning simple interest, this would be $1,000 per year. We would only have $20,000. We would not have nearly $26,000. So the fact that it's compounding even yearly has more than increased our growth by more than 60%, by nearly 60%, sorry. So here, the amount is going to be equal to 25, 9, what was the rest of the number? 37.42. Cool. That's the amount for compounding annually. Now let's take a look at compounding continuously. Sure, just leave that there. Okay, let's type it in. Here, the way we set this formula up is amount is equal to 10,000. That's the principal, multiplied by E raised to the rate times time. The rate was 0.1. So yeah, 0.1. The time is 10. 10 times 0.1 is 1. So the amount here is 10,000 times E raised to the power 1. Okay, fine. Raised to the 0.1 times 10. Okay, that's the exponent that we raise it to. That is 1, people. So, okay, here. Let's see what that is. Okay, clear. Let's do 10,000 multiplied by E. Look, there's a button for it on my calculator. There it is. Let's see how much. Oh, we would have 27,000. Okay, so how much more money is it? It's not that much more, but it's significant. Okay, so the more frequently you compound, the more money you're going to have. And if you compound as frequently as possible, which means an infinite number of times per second, this is the best growth you can hope for just by changing your compounding period. Okay, so now 27,182.81. Okay, so this A is equal to that. Let's call this A2 for compounding continuously, and we'll call this A1. That way we can distinguish them. Now we can solve this with an equation. A2 minus A1 equals, well, let's do it on the calculator. We have this number here, and we're just going to subtract this number. 2, 5, 9, 3, 7.42 equals this number here. You will have 1245.3.4. 1245.4. There. This is how much more money you have by compounding continuously. Therefore, you have annual has two ends, right? So therefore, you have $1,245.40 more money compounding continuously rather than annually. All right. This is compound interest, simple interest, solving for various things. If you're having to solve for t, you may use Desmos. You may use guess and check. Okay. If anyone wants to see an example of that, watch the Delta Math walkthrough that I'll post later. Okay. Thank you very much for showing up for your learning, everyone. Does anyone have any questions before we move on to a question from yesterday? All right, as you're working through your practice problems and as you're working through your Delta Math today, if you have questions, find me here in the chat or find me by email. Or if it's after class time and you're working on this, find me by email. Thanks everyone for showing up for your learning.